Now, let's continue. What we had in our previous discussion is we had this example using /24 network with the maximum usable IP address of 254. But what if we are required to configure or assign 400 IP addresses? Okay, and if you think about it, is our /24 enough? No, the answer is no. Why? Because the /24 only has a maximum of 256 IP address, but 254 usable IP address. Okay, so this is not enough. Here's what I'm gonna do. We're gonna do, we're gonna dissect, okay, our network. We're going to convert our third octet to binary, not only third octet, also the fourth octet, for us to understand how subnetting works. Okay, so what I'm gonna do is I will just carry 192.168. I will just carry 192.168, or I'm gonna use decimal 192.168. The third octet, I'm gonna convert this to binary. Okay, so this will be 8, and then the 4 octet as well, I'm gonna use binary format. There. Okay, so this is the first IP address, and I need space, so let me just move this a little closer. Not this one. Okay, I'm gonna move this a little closer and a little closer to the left. There you go. Okay, and I'm gonna add 0, 0, 0, 0, 0, 0, 0, 0. Okay, so this is our binary value of third octet and fourth octet. And yeah, because this is the first value, all zeros. Now, if I continue, it will be 192.168. 0, 0, 0, 0, 0, 0, 0, 0. That is the third octet, and the fourth octet will be 0, 0, 0, 0, 0, 0, 1. If I continue, I'll just go ahead. Okay, 0, 0, 0, 0, and then I will just use all 0 and change the last 2 bits to 1, 0. Now this is dot 2. I will convert I'm gonna use binary all the way, all zeros all the way up to the last 2 bits. Okay, so this is 3. Now if I continue, it will reach 192.168 0, 0, 0, 0, 0, 0, 0, 0. Then this will be all 1, 1, 1. This is actually the equivalent of all 255. So if I'm gonna convert this, this will be 192.168 0.0, and this will be 192.168 0.1, 192.168 0.2, and 192.168 0.3, and this will be 192.168 0.255. Now maybe you're thinking, why did you change the third octet? Why is now 0? Because we need to borrow a bit from the host to the network. Okay, the reason why is because our maximum usable IP address is not enough. Okay, so we have a maximum usable of 254. We need to borrow. So this is our original. Before we do the borrowing, this is the original divider. Network side, host side. What I'm gonna do is I'm gonna borrow 1 bit. You see that? 1 bit, 1 bit, 1 bit. So the original divider will now be moved here, making these 8, 8, and this is 7 is our network. Okay, the 1 bit here, this 1 bit is now part of the host. So the host total bits is now 8. It's not 8 anymore. It's now 9. How about the network? Well, 8 plus 8 plus 7 is now /23. And if you are wondering what is the maximum usable value or usable IP address for /23, now take note, for /24 we have 256 minus 2. If we borrow 1 bit from the host to the network, you will multiply the maximum IP address to 2. So it will be 256 times 2. This will be 512 minus 2. Why minus 2 again? Because this is the network and this is the broadcast. Okay, so broadcast and the network. 512 minus 2, we have a total of 510 maximum usable IP address. Now, is our network /23 satisfy this requirement for 100 IP addresses assigned to our host and interfaces? Absolutely. Now, maybe you're thinking, why are we using 0 on our third octet? The answer is this. Since this part here, let me highlight, this part here is now part of the host. It cannot be 1, okay? Because our network should be all zeros from the host side. You see this? Okay? It should be all zeros. Now, if I convert this to 1, this will be an invalid host address. Why? Because you set this value to 1. All host bits should be 0 in the network. Okay, so the right value for the third octet is any value that is not odd numbers. So odd numbers such as .1, .3, .5, .21, .51, .50, not 55, .245, all of these odd numbers will be invalid because you are using this value, okay, plus 1. Now, any value that is even, .0, .2, .4, .6, .10 can be valid.